All right, for the last video here, we're going to talk about decimal to hexadecimal conversions. So I want to convert the number, let's use 73 of base 10, and I want to convert it to hex. Okay. How do I do that? Well, we know our place values in hex. Okay. I'm going to show you the hard way, and then I'm going to show you the better way, I think. It's my personal opinion. How do I find out what that is? Well, my place values, I have a ones place and I have a 16s place, right? Okay. So how many 16s can I get out of 73? So the answer to that question is I can get 4. I can get 4 16s out of 73. So 4 16s is 64. 13 minus 4 is 9. It leaves me 9 left over. And so I have 9 for my ones digit. So that's for 49 in base 16, or we can write 49H. The bigger my number gets, the harder this is to do. How many 16s goes into 211? Okay. When we start dividing by 16, we have to multiply, subtract, do the leftovers, stick it in the one spot. And if we get more than 2-digit numbers, if we get above 256, so we're doing 3 or 4-digit hex numbers, then we have to figure out how many times 256 goes in, do the multiplication, subtract. It gets pretty complicated, and we can do it pretty easily. And honestly, there's calculators out there that will do it for you. But on certification tests and for basic understanding, people often ask you to do it manually. So I am going to show you my way to do this problem we talked about up here. How do I convert 73 in base 10 to hexadecimal? Okay. So what I usually do, because doing the direct decimal to hexadecimal conversion is a real pain, I go back to binary. So 73, 73, and use whatever method you want here. I think I'm going to use the divide by 2 method. Okay, 73 divided by 2 is 36 with a remainder of 1. 36 divided by 2 is 18 with a remainder of 0. Okay. 18 divided by 2 is 9 with a remainder of 0. 9 divided by 2 is 4 with a remainder of 1. 4 divided by 2 is 2 with no remainder, and 2 divided by 2 is 1 with no remainder. 1 divided by 2 is 0 with a remainder of 1. Okay, and then we work from bottom to top. So my number is 1, 0, 0, 1, 0, 0, 1. That's 73 in binary. I make my groups of 4, and I convert my 4. This is a 9, and this is 1, 2, 4, 4. 49 in hex. So I don't go directly, especially when you start doing big numbers. Going directly from base 10 into hexadecimal can get really complicated for most people. So I usually do, since binary conversion is easy, decimal to binary, I use the divide by 2 method. You can use the other method if you want. Since that's so easy, I convert it to binary and then convert the binary to hex because I think it's just faster. And obviously I have the 4 digits. I can tell what they are in groups by looking at them because I've been doing this a while. But even if I have to make a little chart, if I'm doing a couple of these and I make the little hexadecimal to binary chart, the numbers 0 through F, it's still a pretty quick method. So I recommend that to you guys as students. If you get and it doesn't happen very often. Usually people ask you to do decimal to binary, binary to decimal, or hex to binary and binary to hex. But when you get those times that somebody says, let's go to base 10 to hex, I would go base 10 to binary and then binary to hex. Okay. It's a couple extra steps, but it's a couple easy steps. It might take a little longer, but it's easy. All right, so that's my recommendation to you.